In today's class, we'll be discussing one more important concept that is known as resistivity or specific resistance. We know that the resistance of a conductor depends on the nature of material. Nature of material is nothing but the resistivity. Recall the factors affecting resistance of a conductor. Resistance of a conductor is directly proportional to length of the conductor. Longer wire will have more resistance. Resistance is inversely proportional to area of cross section. That means if the thickness increases, resistance will decrease. Now you combine both. Resistance become proportional to L by A, where L is the length, A is the area of cross section. Now as resistance is proportional to L by A, you can equate by using a term that is rho or specific resistivity. Refer resistivity of various materials in page 101, and resistivity is measured in ohm meter. In this slide, a problem based on Ohm's law is discussed. Find the current drawn by a tube light from 220 volt source if it has a resistance of 1000 ohm. Given V is 220 volt, resistance of the conductor is 1000 ohm. Use the formula of Ohm's law, V equal to IR, V equal to 220, I is not known, into 1000. So I equal to 220 by 1000 has become 0.22 amperes. Ampere is a SI unit of electric current. That means the tube light draws 0.22 amperes of current. In this slide, factors affecting resistance of a conductor are revised. Resistance is the opposing force by a conductor to the flow of current, This causes heating effect also. Resistance offered by a conductor depends on the factors length, area of cross section, then increase in temperature will increase resistance, and it's different for different materials. That's what we call resistivity, what you have studied in first slide. Even the fourth slide will be recalling the factors affecting the resistance of a conductor, and the fifth slide you will be observing a video where you can understand the factors affecting resistance.
Factors on which the resistance of a conductor depends. Activity. Take a cell, an ammeter, a nichrome wire of length L and 2L, and copper wire of length L. Procedure. Connect cell, ammeter, plug key with connecting wire in series and leave the gap between the free ends of wires. Complete the circuit with nichrome wire of length L between X and Y. Now plug the key. Note the ammeter reading. Say I1 is equal to 2A. Now complete the circuit with nichrome wire of length 2L. Note the ammeter reading. I2 is equal to 1A. We can say that I1 is greater than I2. We can say that resistance of the conductor depends on the length. Now complete the circuit with thicker nichrome wire of length L. Observe the ammeter reading. Say I3 is equal to 4A. We can say that resistance depends on area of cross section. Now complete the circuit with copper wire of a length L and same thickness equal to nichrome wire. And observe the ammeter reading. Say I4 is equal to 3A. We can say that I4 is greater than I1. We can say that resistance depends on nature of its material. Thus, resistance of a uniform metallic conductor is directly proportional to its length L and inversely proportional to area of cross section A. From 1 and 2 are proportional to L by A. Therefore, R equal to rho into L by A. Here rho is proportionality constant called electric resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. The metals and alloys have low resistivity in the range of 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. For insulators like rubber and glass have resistivity of the order of 10 to the power of 12 ohm meter to 10 to the power of 17 ohm meter. The alloys don't oxidize or burn readily at high temperatures. For this, we can use in heating device like electric iron, toaster, bulb, etc. Whereas copper and aluminium are used for power transmission lines.